Let's take a look at the irrational conjugates theorem. So let f be a polynomial function with rational coefficients, and let a and b be rational numbers, such that square root of b is irrational. If a plus square root of b is a 0 of f, then it says that a minus root b is also a 0 of f. So let's take a look at the definition a little bit more. We were looking for a polynomial function with rational coefficients, so we don't want to see any radicals in the polynomial. And so if one of these, for example, this is a factor, we want to be able to get rid of that square root because it wouldn't be there in the polynomial. So if we think about it, if we were to multiply a plus square root of b times the conjugate a minus root b, this is really our pattern of a plus b, a minus b, and you multiply that. That is a squared minus b squared, right? There's no middle term. So here, in this first example, we would have a squared, and then no middle term, minus, okay, root b times root b is just a b. So in this result, there are no square roots, and that's what our goal is. Now, just to kind of show you, if we multiplied by the same value, a plus root b times a plus root b, this is that pattern, a plus b times a plus b. And with this, that pattern is a squared plus 2ab plus b squared. So, this other example, if we multiply this, we would get a squared plus 2a root b, and then plus b. In this result, we see a square root, which is not what we want. So we have to, when we see one root, one solution with a square root, we multiply by what's called the conjugate. Okay, the conjugate. The conjugate, again, is the same exact terms, except for an opposite sign in the center. So this is positive and this is negative, but the same exact terms. So let's try this example. Write a polynomial function f of least degree, so the lowest degree possible, and has rational coefficients, so no square roots, and a leading coefficient of 1. It has zeros at 3, 2, and 2 plus root 5. Now to talk about that for a little bit, before we get started with the problem, is that if we have x equals 3 and let's say x equals negative 2, if those are the solutions, those are our x-intercepts, how do we write that in factored form? So remember, for x equals 3, that would be x minus 3. Then for x equals negative 2, we would say x plus 2. Now thinking about that again, really that is just x minus a minus 2, and that does change to an x plus 2. Right? We just see that we just changed it to the opposite. Now the reason I bring that up is because if you see, for example, 2 plus root 5, x equals 2 plus root 5, how do I write that in factored form? Okay, so it's just this term. So what that would be is x minus 2 plus root 5. Then if we had an x equals 2 minus root 5 as a solution, it's the same thing. X minus 2 plus root 5. Okay, so just first of all, need to know why is it the opposite, right? And notice that inside that they're both negative, okay? And that's because when we write x equals 3 as a factor, in factored form, it's minus 3. Same thing with x equals negative 2. It's actually x minus a minus 2, and then it does change to the positive 2, if we kind of think about it in that way. Now, in the next one, I'll show you how to actually solve this problem.